Alright, so the definition for the internal energy is, we can write it as the sum of all kinetic and potential energies of atoms and molecules in a matter is their internal energy. For example, internal energy. For example, if a molecule or atom is moving with high speed, we will say it has more kinetic energy. So kinetic energy is associated to the motion of the atoms or molecules, and if the molecules are close to each other, we will say they have more potential energy. If they are away from each other, we will say they have less potential energy. So the potential energy is associated to the distance between the molecules, how far the molecules are, so the distance between the molecules. Now in solids, kinetic energy is low. In gases, kinetic energy is high. Similarly, in solids, the potential energy is high, and in gases, the potential energy is low. Alright, so this is a brief concept of internal energy. Now after this one, we will discuss the concept of heat capacity and specific heat capacity. Alright, so for the heat capacity, we can write the amount of heat that is required by an object, to increase its temperature, by 1 Kelvin or 1 degree Celsius is called its heat capacity. Now we can consider the example of water and honey. Honey requires more temperature to increase. Honey requires more heat to increase its temperature by 1 Kelvin or 1 degree Celsius as compared to the water. So we can say honey has more heat capacity as compared to the water. Now we will discuss the specific heat capacity. So specific heat capacity. So there is a slight change in the definition between the heat capacity and the specific heat capacity. So just see it. I'll write with a different color. So specific heat capacity is basically, it's the amount of heat. I just forgot to write heat here. The amount of heat. Alright. Now for the specific heat capacity, I can say the amount of heat that is required by 1 kilogram of a substance, to increase its temperature by 1 Kelvin or 1 degree Celsius. To increase its temperature by 1 Kelvin or 1 degree Celsius. That is called the specific heat capacity. Now there's a formula that is associated to the specific heat capacity and the thermal energy, and we call it as the thermal energy formula, and that formula is this one. Q is equal to mc delta T, where Q is representing the thermal energy, or we can say the heat. M is representing the mass. C is representing the specific heat capacity. And delta T is representing the change in temperature. So this is the formula for the thermal energy. Alright, so this is it for heat capacity and the specific heat capacity. Now in the next phase we have to discuss the concept of the melting, freezing, boiling, condensation. The process of, now we have to discuss the process of melting. Alright, so melting happens when a solid substance converts into liquid. That is melting. Next one is solidification or freezing. So solidification or freezing happens when a liquid converts into solid. Then comes boiling. So the boiling happens when a liquid is converted into gas. And the next one is condensation. So condensation happens when a gas is converted back into liquid. And now we have to discuss the melting point and the boiling point. So the melting point is basically melting point, it's the temperature at which the solid converts into gas. That's the melting point. And for the boiling point, we can say, for the boiling point, it's the temperature. I'll write with some other color. So temperature at which liquid converts into gas. That's the boiling point. Now we will discuss the difference between the boiling and evaporation. Alright, so now we have to discuss the difference between the boiling and evaporation. So let's discuss the boiling first of all. So boiling happens, let's suppose we have some liquid. This is the liquid, and we are heating the liquid. So this is the burner, this is the flame that is heating the liquid. Now there is some pressure by the atmosphere onto the surface of the liquid, so we call that as atmospheric pressure. The liquid will remain liquid until or unless its pressure does not overcome the atmospheric pressure. So when we have a liquid over here, it has less pressure than the atmospheric pressure. So when we heat up the liquid, the pressure of the liquid increases. So when the pressure of the liquid increases, there comes a point where the pressure of the liquid overcomes the atmospheric pressure, and at that point the liquid starts to convert into gas, and we call that process as boiling, and that temperature is called the boiling point. So I'll write it over here. In boiling, the liquid pressure overcomes the atmospheric pressure, and converts into gas. That process is called boiling, and the point at which the temperature at which its pressure overcomes the atmospheric pressure, that temperature is called the boiling point. So the temperature at which it overcomes the atmospheric pressure, is called the boiling point. Boiling point. Alright, now we will discuss the process of evaporation. Alright, so evaporation. So we can write it as it happens when the high energy molecules in the liquid escapes the surface leaving behind low energy molecules. As a result of which the temperature of the liquid falls. The temperature of the liquid falls, and that process is called evaporation. So for example, we have a liquid in a container. So this is the liquid. Now within this liquid we have some high energy molecules and some low energy molecules, or we can say that the molecules on the surface, they take the energy from the molecules that are underneath the surface. So these molecules get the kinetic energy, so they become so much energetic that they escapes the liquid surface. So when they escape the liquid surface, the overall energy of the liquid decreases. So when the overall kinetic energy of the liquid decreases, they cause cooling, and the process of escaping the high energy molecules from the surface of the liquid is called evaporation. And one more fact that I want to let you know is that boiling happens only at the boiling point, but evaporation happens at all the temperatures until or unless we have a liquid. Alright, so I'll write it here. Evaporation happens at all temperatures, and the boiling only happens at the boiling point. So until the molecules are getting the energy, enough energy to escape the liquid surface, evaporation will keep on happening. So this is the concept of evaporation. Now after this one we will discuss the concept of latent heat and the specific latent heat. So latent heat. So latent heat is basically, it is the amount of heat required to change the state of matter, either from solid to liquid or from liquid to gas, without changing the temperature, that is called the latent heat. So when the state of the matter changes from solid to liquid, we call that latent heat as latent heat of fusion. Latent heat of fusion. And when the state of the matter changes from liquid to gas, we will call it as latent heat of vaporization. Latent heat of vaporization. So this is how we can define the latent heat. Now we will discuss the specific latent heat. So I'll write down the definition of it. There's a slight difference between the definition of latent heat and the specific latent heat. So specific latent heat. So it is basically the amount of heat required by 1 kilogram of substance to change its state, whether from solid to liquid or from liquid to gas. And if it changes its state from solid to liquid, it will be called the specific latent heat of fusion, and if it changes its state from liquid to gas, it will be called the specific latent heat of vaporization. And the thermal energy formula for the latent heat, okay, I have to mention one more thing over here. 1 kilogram of substance to change its state without changing the temperature, without change in temperature. Okay, and the formula is Q equals to mL, where L represents the specific latent heat. Specific latent heat. If the substance is converting from solid to liquid, it will be called specific latent heat of fusion. If the substance is converting from liquid to gas, it will be called the specific latent heat of vaporization. M is the mass, Q is the heat that has been absorbed. Alright, so this is about the latent heat and the specific latent heat. Alright, now we will discuss what happens to the molecules when they're changing their state. So when they're going from the solid to liquid or from liquid to gas, we will discuss the latent heat at the molecular level. Alright, so latent heat in terms of molecular behavior. So let's suppose this is solid, where the molecules are very close to each other. They're so much. And now let's suppose we have a liquid over here, where the molecules are at moderate distances from each other. So they are in regular arrangement, and they are at the moderate distances from each other. So when the solid converts into liquid, then the latent heat is required to break the intermolecular forces between the molecules of the solids. And when the intermolecular forces are broken down between the molecules, then the molecules move away from each other. So this process happens at the melting point. At the melting point, the solid converts into liquid, and the latent heat that the solid is absorbing is required to break the bonds between the molecules of solid. Bonds between the molecules of solid. So this is the application of latent heat when melting happens. The the bonds are broken down, so that is why all the heat is being utilized to break the bonds, to break the intermolecular forces between the molecules, and that's why the temperature does not increase. Same happens at the boiling point. So at the boiling point, the liquid converts into gas. So let me just erase some molecules and make it look like the liquid. So this is a liquid where the molecules are at moderate distances from each other, and this one is gas where the molecules are quite far from each other. So this process happens at the boiling point, and over here the latent heat is required to break down the bonds between the molecules of liquid and converts them into gas. So when the molecules between the liquids are when the bonds between the molecules of the liquid are broken down, they move further away from each other, and the state of the liquid changes into gas, and all the heat that is being absorbed by the liquid will be used to break the bonds instead of increasing the temperature. So the temperature at the boiling point remains constant until all the liquid converts into gas. Same happens for the melting point. At the melting point, the temperature will remain constant until all the solid converts into liquid. So this is the molecular behavior of the this is the molecular behavior of the latent heat, and this is how latent heat is utilized in changing the state from liquid to from solid to liquid and from liquid to gas. Okay, now we will discuss the concept of thermal expansion, the thermal expansion of solids, liquids and gases, and then we will see some everyday examples of that thermal expansion and the consequences of that. Alright, so the thermal expansion of solids, liquids and gas. So generally all solids, or we can say the solids, liquids and gases expand upon heating, and gases expand on heating, although the magnitude of expansion is different. So solid expands minimum, the expansion of liquid is more than solids, and the expansion of gas is more than liquid and solid. So this is the order of expansion of solid, liquid and gas. We can say it as the order of expansion. Now the expansion depends on the potential energies and the kinetic energy of the molecules. If the molecules are close to each other, they have high potential energies. If they are away from each other, they have less potential energies. So when they are away from each other, or if we can decrease their potential energy or increase their kinetic energy by providing the heat, then they will expand. So that process is more prominent in gases as compared to the solids, because in solids the molecules are very close to each other, so they do not expand that much as compared to the gases. So the magnitude of expansion depends on the magnitude of expansion depends on the kinetic energy of the molecules of solids, liquids and gases. Of solids, liquids and gases. So the more energy, the more kinetic energy the molecules will have, the more they will expand. And in gases, the molecules gain more kinetic energy as compared to the solids, so that's why the gases expand more as compared to the solids. So this is about the concept of thermal expansion and the magnitude of thermal expansion. Now we will see some everyday applications or the uses of that thermal expansion. So the most prominent example is of the thermometer. So let's suppose this is a thermometer. It's a liquid thermometer in which the liquid is mercury, and let's suppose the level of the mercury is up till here. So if the temperature over here increases, temperature increase will expand this liquid, and when this liquid expands, the level of this liquid will increase up to, let's suppose, this limit, this level. Now due to the heat, the temperature, the liquid in the thermometer has expanded, and so that we can measure the temperature according to that expansion. So this is a very common example for the thermal expansion of solids, liquid or gases. Over here I'm only discussing the example of the liquid. Now what happens to a gas whose temperature increases without increasing at a constant pressure? So let's discuss that. So let's suppose we have a gas. This is a cylinder. It is a piston on the cylinder, and there are gas molecules in the piston. We are increasing the temperature of the gas by burning a burner. So here's the burner, this is the flame of the burner. So when the temperature increases at the constant pressure, the volume of the gas will increase. Why? Because with the increase in the temperature, the kinetic energy of the gas molecules will increase. When the kinetic energy of the gas molecules will increase, they will move away from each other, and due to which the volume of the gas will increase. They will expand, the gas will expand. Alright, so I'll write it over here. Increase in temperature of gas, increase in temperature of gas increases the kinetic energy of molecules. So at a constant pressure, the molecules move away from each other, and the volume increases. So the volume of a gas at any particular fixed pressure is directly proportional to the temperature. The more temperature you increase, the more expansion you will see. Alright, so this is it for this chapter of the thermal properties of matter, and I hope you understood it. If you have any question, you can just write in the comment section, and do subscribe the channel so whenever I upload any video you'll be notified quickly. So this is it for this chapter, and I hope you will understand it well. Thank you so much.